Hey everyone, let's jump right into today's explainer. We are tackling something absolutely crucial for building AI that actually works out there in the real world. I mean, we hear about these incredibly smart AI agents all the time, right? But how do we actually make them reliable? Well, it all starts with the data layer. In plain English, we're going to explore why this foundational step is quite literally the make or break moment for any AI system you build. I want you to think about this powerful insight from Dr. Şükrü Imre's research. He says intelligence cannot emerge without data. And honestly, it's just a fundamental truth. It doesn't matter if you have the most incredibly smart, wildly expensive AI model on the planet. If it doesn't have a clear, accurate view of reality, it's completely useless. The data is what actually grounds the AI in the real world. Picture a veteran warehouse manager walking in for their morning shift. Before they make a single decision or assign a single task, what do? They check their clipboard. They need to see the daily roster, figure out who called in sick, and look at the actual work orders. Without that basic, raw information, all their years of experience don't mean a thing. Well, an AI agent is exactly the same. It relies on the data layer as its own personal clipboard. It needs those eyes to see the raw facts of the day before it can even start to do its job. So, here is our blueprint for today. We're going to cover the AI agent's eyes, define what the data layer actually is, and track down where that data lives. Then we'll ground it all with a warehouse management case study, tackle our biggest enemy, bad data quality, and wrap up by building a solid foundation. Okay, section 1, the AI agent's eyes. Seeing the raw reality. The crucial takeaway here is that classic rule you've probably heard a million times: garbage in, garbage out. You see, at this specific stage in the architecture, the AI isn't doing any complex thinking yet. There's no interpretation happening, no decisions being made. It is strictly collecting raw facts. But if those facts are wrong or incomplete or just messy, everything you build on top of them is going to break. Clean data is absolutely non-negotiable. Moving on to section 2, what is the data layer? The 3 big questions. To define this clearly, without getting bogged down in crazy technical jargon, we just need to answer 3 super simple questions. First, where is the data? You have to know its exact address. Second, what format is it in? Is it a text file, a structured table, maybe a JSON file? That format tells the AI exactly how to read it. And third, how fresh is it? Does this stuff update in real time, or are we looking at a spreadsheet from last week? The answers to these 3 questions basically dictate how your AI interacts with reality. All right, section 3. Where does data live? Feeding the agent. Let's look at the real-world places our AI goes to get its information. Because let's face it, data rarely comes from just one place. You've got your 5 common suspects here. Usually people start with Excel or CSV files because they're fast and cheap. But as things scale, you start plugging into those big corporate systems, like SAP, for the really rich information. Then you have IoT and sensors. Think barcode scanners on a warehouse floor. You've got API connections to instantly pull things like live weather or shipping statuses. And of course, your standard relational databases, keeping everything structured. Now, to connect all these different sources seamlessly, we use something called an MCP, which stands for Model Context Protocol. Just think of MCP as a standard bridge. Instead of having a human manually upload an Excel file every morning, this bridge lets the AI safely and automatically pull live data straight from those corporate systems. It can literally grab work orders right out of SAP, ensuring the AI always has the absolute freshest version of reality. Section 4, the warehouse management case. Let's make this real. Concepts are great, but it's so much easier to understand when we look at a tangible example. Let's see how an AI agent actually views a busy logistics warehouse. The AI looks at reality through structured tables. Take a work order table, for instance. This is where the AI sees the physical work that needs to get done, just raw, undeniable facts. Each row is a specific tour an operator has to complete. It shows exactly how many products they need to pick up and the physical volume of those products. But the AI can't just look at the work in a vacuum, right? It needs a second table, the operator table. The AI obviously can't assign tasks if it doesn't know who's actually in the building. This table tells the agent exactly who is active on the floor today and who happens to be sick or on leave. And I want you to just look at the sheer scale of this. For this specific warehouse, in just a single day, the AI is instantly ingesting 74 different tours that cover over 5,000 individual products. It's processing all of this raw data in a fraction of a second to map out the entire day's operations. That's pretty wild. Now, along with those tables, the AI needs constraint parameters, basically the rules of the game. The AI has to know that a tour takes about 40 minutes on average. It needs to know that a worker has exactly 435 minutes of efficient working time in their shift. And legally, they can only do a maximum of 10 tours a day. These constraints put up the guardrails, telling the AI exactly what is physically and legally possible. Section 5, the enemy. Bad data quality. When the foundation cracks. Because collecting data just isn't enough. It has to be reliable. Bad data is hands down the biggest enemy of a reliable AI agent. Let's run through a quick checklist of complete disasters. First, missing data. If an employee's status is just completely blank, what does the AI do? Does it assign them work or not? Second, inconsistent formats. If you mix up kilograms and cubic decimeters, you are going to totally break the AI's math. Third, outdated records. Say someone came back from vacation, but the system hasn't updated yet, the AI just won't give them any work. And fourth, outliers. Imagine a tour listed with a volume of 500 when the average is usually around 195. Is that a real massive order, or did someone just add an extra zero by mistake? Every single one of these simple errors completely derails the AI. So here is the bottom line. You absolutely must catch and fix these errors at the very bottom, in the data layer. Down there, fixing a blank cell or fixing a typo is cheap. It's easy. But if you let that bad data travel all the way up into the agent layer, those mistakes snowball. The AI will start making these incredibly weird, expensive decisions that make absolutely zero sense to anyone, and good luck trying to reverse engineer why it did it. Which brings us to Section 6, building a solid foundation, getting ready for the next step. We've seen how the data layer is the invisible foundation of this whole setup. So before you move forward with building out your agents, run through this final checklist. Ask yourself, what specific data types does your system actually need to function? How exactly is it going to be accessed? Are we talking flat files or a live bridge like MCP? What processes do you have in place to guarantee that data is actually accurate? And mechanically, how does the AI connect to it? If you can answer those straightforward questions, your foundation is rock solid. But I want to leave you with kind of a wild thought. Let's say we did everything perfectly. Our foundation is flawless, our AI has all the clean, fresh data in the world. It looks at the table and sees on leave. It sees cubic decimeter. But right now, sitting at this layer, the AI still knows absolutely nothing. It doesn't actually know what on leave means for a living, breathing human being. It doesn't know what a cubic decimeter represents in the physical world. So how do we give all this raw data actual real-world meaning? Well, that massive leap is the job of the next step in the architecture, the semantic layer. But that is a whole other topic for another day. Thank you so much for joining me on this explainer, and keep building those solid foundations.